The periodic table. What is periodic table? A table of chemical elements are arranged in order of increasing atomic number. A brief history of the periodic table. The periodic table of elements is a common sight in classrooms, campus hallways and libraries, but it is more than a tabular organization of pure substances. Scientists can use the table to analyze reactivity among elements, predict chemical reactions, understand trends in periodic properties among different elements and speculate on the properties of those yet to be discovered. The modern periodic table arranges the elements by their atomic numbers and periodic properties. Several scientists worked over almost a century to assemble the elements into this format. Among the scientists who worked to create a table of the elements were Antoine Lavoisier, Johann Wolfgang Dobereiner, John Newlands and Henry Moseley. In 1789, French chemist Antoine Lavoisier tried grouping the elements as metals and nonmetals. 40 years later, German physicist Johann Wolfgang Dobereiner observed similarities in physical and chemical properties of certain elements. He arranged them in groups of 3 in increasing order of atomic weight and called them triads, observing that some properties of the middle element, such as atomic weight and density, approximated the average value of these properties in the other 2 in each triad. A breakthrough came with the publication of a revised list of elements and their atomic masses at the First International Conference of Chemistry in Karlsruhe, Germany, in 1860. They concluded that hydrogen would be assigned the atomic weight of 1 and the atomic weight of other elements would be decided by comparison with hydrogen. For example, carbon, being 12 times heavier than hydrogen, would have an atomic weight of 12. British chemist John Newlands was the first to arrange the elements into a periodic table with increasing order of atomic masses. He found that every 8 elements had similar properties and called this the law of octaves. He arranged the elements in 8 groups but left no gaps for undiscovered elements. In 1869, Russian chemist Dmitry Mendeleev created the framework that became the modern periodic table, leaving gaps for elements that were yet to be discovered. While arranging the elements according to their atomic weight, if he found that they did not fit into the group, he would rearrange them. Mendeleev predicted the properties of some undiscovered elements and gave them names such as Aka aluminium, for an element with properties similar to aluminium. Later Aka aluminium was discovered as gallium. Some discrepancies remained. The position of certain elements, such as iodine and tellurium, could not be explained. German chemist Lothar Meyer produced a version of the periodic table similar to Mendeleev's in 1870. He left gaps for undiscovered elements but never predicted their properties. The Royal Society of London awarded the Davy Medal in 1882 to both Mendeleev and Meyer. The later discovery of elements predicted by Mendeleev, including gallium, 1875, scandium, 1879, and germanium, 1886, verified his predictions and his periodic table won universal recognition. In 1955, the 101st element was named Mendeleevium in his honor. The 1869 periodic table by Mendeleev in Russian, with a title that translates "An experiment on a system of elements based on their atomic weights and chemical similarities." The concept of subatomic particles did not exist in the 19th century. In 1913, English physicist Henry Moseley used X-rays to measure the wavelengths of elements and correlated these measurements to their atomic numbers. He then rearranged the elements in the periodic table on the basis of atomic numbers. This helped explain disparities in earlier versions that had used atomic masses. In the periodic table, the horizontal rows are called periods, with metals in the extreme left and nonmetals on the right. The vertical columns, called groups, consist of elements with similar chemical properties. The periodic table provides information about the atomic structure of the elements and the chemical similarities or dissimilarities between them. Scientists use the table to study chemicals in design experiments. It is used to develop chemicals used in the pharmaceutical and cosmetics industries and batteries used in technological devices. Feature of the periodic table. Group vertical column of the periodic table based on the organization of the outer shell or valence electron. Groups of elements in periodic table. Group 1 of the periodic table consists of hydrogen and the alkali metals. Hydrogen is a very reactive nonmetal. The alkali metals are the most reactive metals. Group 2 consists of the alkaline earth metals. They are very reactive but less so than the alkali metals. Group 3 to 12 contain transition metals. They are less reactive than metals in groups 1 and 2. Groups 3 to 12 of the periodic transition metals have more valence electrons and are less reactive than metals in the first two metal groups. The transition metals are shiny. Many are silver-colored. They tend to be very hard, with high melting and boiling points. You can read more about radioactive elements in the chapter Nuclear Chemistry. Many of the actinides do not occur in nature but are made in laboratories. Groups 13 to 16 each contain at least one metalloid. They also contain metals and/or nonmetals. Elements in these groups vary in reactivity and other properties. Group 13 is called the boron group. The only metalloid in this group is boron. The other four elements are metals. All group 13 elements have 3 valence electrons and are fairly reactive. All are solids at room temperature. Group 14 is called the carbon group. Carbon, C, is a nonmetal. The next two elements are metalloids, and the final two are metals. All the elements in the carbon group have 4 valence electrons. They are not very reactive. All are solids at room temperature. Group 15 is called the nitrogen group. The first two elements in this group are nonmetals. These are followed by 2 metalloids and 1 metal. All the elements in the nitrogen group have 5 valence electrons, but they vary in their reactivity. Nitrogen is not reactive at all. Nitrogen is a gas at room temperature. The other group 15 elements are solids. Group 16 is called the oxygen group. The first 3 elements in this group are nonmetals. They are followed by 1 metalloid and 1 metal. All the elements in the oxygen group have 6 valence electrons, and all are reactive. Oxygen is a gas at room temperature. The other 4 elements in group 16 are solids. Group 17 contains halogens. They are highly reactive nonmetals with 7 valence electrons. The halogens react violently with alkali metals, which have 1 valence electron. The two elements combine to form a salt. For example, the halogen chlorine, Cl, and the alkali metal sodium, Na, react to form table salt, or sodium chloride, NaCl. The halogen group includes gases, liquids, and solids. For example, chlorine is a gas at room temperature, bromine, Br, is a liquid, and iodine, I, is a solid. Group 18 consists of noble gases. They are unreactive and rarely combine with other elements. They are all colorless, odorless gases. Their outer energy level is also full, so they are the least reactive elements. In nature, they seldom combine with other substances. Period is the horizontal row of the periodic table. There are 7 period which starts from the far left. Elements on the same period has the same atomic orbital, and every new period the principal energy level also increases. Period 1 have 2 elements. Period 2 have 8 elements. Period 3 have 8 elements. Period 4 have 18 elements. Period 5 have 18 elements. Period 6 have 32 elements, including lanthanide series, rare earth metal. Period 7 have 32 elements, including actinide series, rare earth metal. Periods 6 and 7 have 32 elements because the 2 bottom rows that are separated from the rest of the table belong to those periods. They are pulled out in order to make the table itself fit more easily onto a single page. Periodic properties. Atomic sizes. Atomic radius decreases from left to right. Atomic radius increases from top to bottom. Ionization potential or energy. Ionization energy increases from left to right, decreases from top to bottom. Electron affinity. Electron affinity increases from left to right, decreases from top to bottom. Electronegativity. Electronegativity increases from left to right, decreases from top to bottom. Oxidizing and reducing properties. Oxidizing property increases from left to right while reducing property decreases. Oxidizing property decreases from top to bottom while reducing property increases. Usefulness of periodic table. Most useful tool to a chemist or people who study chemistry. Aids us to study the elements in an orderly and systematic approach, makes us familiar with the properties shared by certain elements belonging to a similar group, gives us an idea in predicting the properties and uses of an element.